all rocks come from volcanoes. Many rocks that we actually have around us are actually formed from the remnants of previous rocks that have been broken down thanks to all of the plate tectonics and weathering we've been talking about. They're called sedimentary rocks. There are three types of sedimentary rocks that you really need to understand about. Clastic are ones that are made from broken down pieces of rock cemented together. Organic are made from dead things like trees and animals squished together to form a rock. Chemical one is a little bit hard. They're not made from rocks. They're made from dissolved shells, dissolved skeletons, all of those sorts of things. So basically, if you're going to dissolve something, you need water. So these are found at the bottom of water bodies like the oceans, where shells and skeletons have been dissolved and they actually re-solidify, and all of the solidified crystals drop to the bottom of the water body and start to form layers. This is a very special type of rock called limestone. You're going to have a look at that in a minute. Clastic sedimentary. Here's an example, conglomerate. See all the pieces of rock there and all the little pieces of sand in between cemented together, conglomerate. Here's another example of a sedimentary rock, breccia. The only difference between this one and conglomerate is this has sharp edges on it and conglomerate has round edges on it. Conglomerate, if you've got round edges, conglomerate comes from areas where it's been washed around in water and sanded down. Breccia is where you've had rocks chipped away and broken up, but they haven't been worn down by areas of water. So these normally form on land, whereas conglomerate will often form near water bodies where the rushing water has worn them down. Here's another one, sandstone. Now this is often found in deserts, lots and lots of fine sand particles stuck together. There's another type of clastic rock, but it's made out of even finer particles of mud. This is mudstone. Now, when you have clastic rocks, basically they're named after the sediments that they're made from. We break them up depending on the size of the sediments. So you get from very fine particles, which we call mud, up to particles that are 1/16 to 2 millimeters in size. We call that sand. And if it's bigger than that, we call it gravel, okay? So here they are. Mud, depending on how fine it is, will form stones like shale and siltstone. Sand, of course, forms sandstone. And gravels will form either breccia, if they're really sharp, or if they're rounded, conglomerate. And it's very easy, once you know where these sediments come from, to start to think of the story about these rocks and where they came from. Mud, we normally find happens and gets put down in flooding. Sand is going to be either something to do with the oceans or with deserts. Get them in there too. And gravel, of course, well, as I said, conglomerate are all rounded fragments, very nice and smooth. So usually you find them in running water bodies, at the bottoms of creeks and streams, because that's how they got worn down and rounded. And of course, breccia, you find that more on the land because things have broken up the rock, but they haven't been smoothed down like they would have been in water. So literally, you're starting to get a picture of the rocks and where they came from. Now, organic sedimentary rocks come from things that were once living, and that's either plants and animals or even smaller organisms that you don't normally see with the naked eye. This here is peat. It's not a rock, okay? But peat, P-E-A-T, is a precursor to coal, and it contains an awful lot of decomposing plant matter, often found in areas that were covered by swamps with lots of trees and decaying plants. And here is what happens to it when it is squished down and put under huge amounts of pressure for a long time. It turns into coal. Now, chemical sedimentary, I wanted to go into this in a little bit more detail. When you have an area covered by water and you have lots of animals in it and shellfish, different types of fish, they all have shells and skeletons which contain something called calcium carbonate. Now when you have this in water, it tends to dissolve, especially if you have water that's not near a neutral pH. Anyone who's seen their fish tank and doesn't clean it knows that after a while the shells of their snails look pretty sad because they're literally dissolving in the water. Well, if you get enough of those dissolved shells getting dissolved in that water, and the water starts to evaporate because of the sun, eventually those dissolved shells have such a concentration that they actually start to precipitate and turn back into a solid. And as those solid previously dissolved shells fall to the bottom, you end up with this layer here of calcium carbonate. Calcium carbonate is also what our teeth are made out of, but when it precipitates like this, we call it limestone, and is often accompanied with layers of sand because it came from an area that was covered in water. And here is an example of chemical sedimentary rock. These are the White Cliffs of Dover, and they are huge. If you're wondering what I'm talking about, look at the size of the lighthouse compared to all of this rock. So imagine all of this rock came from dissolved shells and dissolved skeletons of fish that got deposited on the bottom of an ocean. So this used to be under the water, and it ended up being so thick that it's the height of many, many different buildings on top of each other. I'm not sure how high, but as you can see, very high. So this used to be under the water. Plate tectonics has lifted this up and exposed it. Most probably has worn away a lot of this as well. It would have had sand on top of it as well if it was at the bottom of the ocean. Exposed these cliffs and allowed us to see what used to be there before. Now, when you have sedimentary rocks like these, they often contain fossils, as you can imagine, because if things are continually being laid down, often animals get caught in there, or plants. So you'll see lots of different things like the impression of a body, or you'll see skeletons or exoskeletons. And often you'll find that if there's soft body tissue, the minerals that are in the sediments around it will actually go in and fill up the cells and replace the tissue, but actually keep the shape of the animal preserved. So here we've got some examples here of fossils that are encased in sedimentary rock. Some more there. So to sum it up, here are our three different types of rock. Each one of them and their component rocks has a different story. Clastic, different pieces of broken down rock cemented together. Remember that each one of those, especially when you look at breccia and conglomerate, have their own little story about how they got smoothed down or broken up. Organic is dead stuff, and chemical is dissolved minerals, which often come from shells and skeletons of living organisms.